So in this video I want to explain about the subspace topology. Okay, so suppose we've got a topological space X. And suppose we've got a subset. Okay, so the idea now is we want to make Y into also a topological space. Okay, so we need to define a topology on Y, and if you recall, what's the definition of a topology? A topology is a collection of subsets of your set. Okay, so we'll say that a set V, a subset of Y, is open in Y if there exists a subset U of X, which is open in X. In other words, it's remember we've got a topology on X, and the topology is a collection of sets which are called open sets. So U is supposed to be one of those, such that V is equal to U intersected with Y. Okay. So the idea is kind of like this: that you take subsets that are open in X and you intersect them with Y, and then you get sets that are open in Y. So the picture you should think of is kind of like this. Here's your set X, and maybe here's Y, and you've got some subset here. This is your subset V, and you want to know whether it's open in Y or not. And to show that it's open in Y, what we have to do is we have to find this kind of set U, which is open in X, such that the intersection of U with Y is equal to this V that we're looking at. So the claim is that this definition of what we mean by a subset of Y being open gives a topology on Y, which we call the subspace topology. Okay. So for the proof, what does it mean to say that something's a topology? Remember, there were three axioms. Firstly, the open set, the empty set, and the whole space, they're supposed to be open. And the union of any family, even an infinite family of open sets, is supposed to be open. And the intersection of any finite family of open sets is supposed to be open. So that's what we need to check. So what's the empty subset? Well, that can be described as the empty set intersect Y, with the empty set being open in X. Therefore, the empty set is open in Y. Right? Remember, in order to show that some subset of Y is open, we need to find some subset of X that's open and intersect it with Y and see what we've got. Okay, so here the empty set, well, that's open in X. That's one of the axioms for having a topology on X, and then we intersect it with Y, we just get Y. So that's good. Also, the subset Y, and that can be described as X intersect Y, with X open in X. And so that means that Y is open in Y. Okay, so those are the two halves of axiom A. So now let's suppose we're given a family of open subsets of Y. A family of subsets. So VI for I in some index set, VI open in Y. Okay, then we have to show that the union of all those, so let's call that union V upper star. V upper star is the union over I of all these subsets Vi. So we must show this is also open in Y. Now, as Vi is open in Y, I mean that's our assumption here. Remember, that means we could find some UI open in X with Vi being UI intersect Y. Okay, that was the definition of the subspace topology. Sets open in Y if and only if it's the intersection of an open subset of X with Y. Put U upper star, so that's going to be the union of all these UIs. So that's open in X. That's by an application of axiom B for X. Remember, X we're assuming is a topological space, so therefore in X the union of any family of open sets is open. And then it's easy to see that V upper star is just the same as a U upper star intersect Y. Therefore V star is open in Y as required. And then there's axiom C. So now let's suppose we're given a finite list. So V1 up to Vn of open subsets of Y. And then let's put V hash is V1 intersect V2 up to Vn, the intersection of this finite list. You need to show that V upper hash is again open in Y. And the proof's more or less the same as the previous thing. Again, you can find UI open in X with Vi being equal to UI intersect Y. That's because Vi is assumed to be open in Y, and that's the definition of what that means. And then we put U upper hash is U1 intersect up to UN, which is open in X by the same axiom for X, which we're assuming is true. And then we note that V upper hash is just the same thing as U upper hash intersected with Y, and therefore V hash is open in Y as required. Okay, so that proves that we've got a topology which is called the subspace topology, and we'll investigate its properties in the next video.